Levenshtein's distance is used in linguistics to compare two strings to each other. Its purpose is to find the cheapest way to convert one string so that it matches the other one. In this tutorial, we will go through an example on how to create a Levenshtein distance table, and we will analyze it to find the cheapest path. Let's dive into it. We want to compare learning to machine. So what is the cheapest way to convert the string learning to machine? We start by initializing a matrix, as you see in the table, and we initialize the first column and the first row. We start with 0 on the first cell, and we increment each cell with +1 until the length of the word. To add a value to a cell, we need to look at its neighbors. And now we look at the letters that we want to compare. Is L equal to M? And it is not. So we take the lowest value of the neighbors and add +1 to it. And now we go forward. Is L equal to A? And it is not. So we take the lowest value of the neighbors and add +1 to it. Now we have two values that are equally low, so we can choose either of them, and we add +1. We continue to the next cell. Is L equal to C? And it is not, so we choose the lowest value of the neighbors again and add +1 to it. Now we have two number 2s, so we can choose either of them. We continue to the next cell. Is L equal to edge? And it is not, so we take the lowest value of the neighbors and add +1 to it. We repeat this process until we reach the last cell. Here we stop, because E is equal to E. So we take the lowest value of the neighbors and add nothing to it. We just take it and put it in the cell. We found two equal letters again, so we take the lowest value of the neighbors and just place it in the cell. And now we continue our journey. Now that we have completed the table, we can see that the Levenshtein distance is 5. To find the cheapest way to convert learning to machine, we need to start on the first cell and walk through the table down to the golden bar. You can view this as a labyrinth. We start on one side and we want to end up on the other one. And along the way, we need to do the right choices. In this case, we want to select the cheapest options that takes us along the line. And this is one of the cheapest ways to convert learning to machine. Let's break it down. We start on the first cell. we change L to M, we remove E, we keep A, we change R to C, we change N to edge, we keep I, we keep N, and we change G to E. There can be more than one cheapest way. It doesn't necessarily have to be like this one. You can choose your own path, as long as you select the cheapest options. For example, let's look at our options after that we have modified L to M. We could either insert A, replace E with A, or remove E. All three options cost the same, so we could choose either of them. And this was the tutorial on Levenshtein Distance.